Here's an example in which we start with a function right here, and we have to pick the correct graph. Like maybe it's this one, or this second one, or this third one, or this fourth one. It's multiple choice, pick the right graph. So this function we're looking at, how do we go from this function to that or that, etc., the right graph? Well, we have to know a couple things. So first off, the denominator equal to 0. Whatever makes the denominator equal to 0, those are going to be vertical asymptotes, aren't they? So let's take the denominator right here. And you could start with the numerator. It doesn't matter. I'm just grabbing the denominator. So whatever makes that denominator equal to 0. Well, I think we can see whatever makes x plus 1 0, or whatever makes x minus 4 0, right? Because these two things are multiplied together, equaling 0. So anything that makes either one 0, since they're multiplied, will make the whole thing 0. So you know the deal here. So x is negative 1, or x is 4. So negative 1 or 4 are going to be vertical asymptotes. So negative 1 and 4, vertical asymptotes. That looks good. Negative 4, nope. This is the wrong answer. This one's out. Yeah, let's do it that way. Negative 4 again, nope, that's wrong. Negative 1 and 4, yeah, that's a candidate. So we still have two candidates left that have negative 1 and 4 as vertical asymptotes. Next, we have to take the numerator, and whatever makes the numerator equal to 0, whatever makes the top of a fraction equal to 0 is going to be an x-intercept. Now, why is that? I don't want to just give you these math rules without reasons. Do you remember you remember what a division is? If we go 10 divided by 2, the answer is 5, of course, because 2 goes into 10 5 times, right? So what if I go 0 over 2? Well, again, bottom into top. That's what a fraction means, bottom divided into top. You know that. How many times does 2 go into 0? Well, 0, of course. Right. So what if we put it the other way, though? What if we put the 0 on the bottom? How many times does, again, bottom into top? See how all these are bottom into top, bottom into top, bottom into top. That's what a fraction means. It means the top divided by the bottom. The bottom goes into the top. How many times does 0 go into 2? Infinite. That's different, isn't it? So 0 in the denominator equals infinity. That's why it's a vertical asymptote, because it goes up to infinity. See how it goes up to infinity, or negative infinity. If that was a negative 2, it'd go to negative infinity. It goes up or down to positive or negative infinity when 0 is in the denominator. Get rid of that, just 0 in the denominator, right? Whereas 0 in the top, 0 in the numerator just means the thing is 0. So 0 in the numerator, that's just going to make y equals 0, because this is y, right? The function values are y values. That's by common agreement in the math science world. F of x, g of x, h of x, function values are y values. So whatever makes the numerator equal to 0 makes the whole function 0, makes y 0, height is 0, right? Just like the top of a fraction is 0, the whole thing is 0. So if the top up here is 0, 0 over anything is going to be 0. So y will be 0. So what makes the numerator 0? Let me grab the numerator here. It's x plus 2 times x minus 3. What makes that 0? Same deal. Either one could be 0 because they're multiplied together. Either one could be 0. If they're multiplied together, it'll be 0. Subtract 2 from both sides. Negative 2. Add 3 to both sides. Boom, boom. Positive. So negative 2 and positive 3 are the things that make y 0. So negative 2, yeah, that's right. Look at that. Negative 2, 0. And x of negative 2 goes with y 0. And 3, right? 3, 0. Yeah, perfect. Look at that. Over 3, up 0. That's looking good. How about this other one that was a candidate? We're supposed to have negative 2, 0. see. Oh yeah, that looks good too. Negative 2, 0. And this one, oh yeah, he's still in the running. They're both looking good, aren't they? They both have those x-intercepts. They're x-intercepts, right? They're places that hit the x-axis. The height is 0. And the same x-intercepts here, hit the x-axis, height 0. So, okay, how are we going to distinguish then which one is which one? Well, what we're going to have to do is take a look at the y-intercepts. That's going to probably be the only difference. See how this one has a y-intercept, looks like between -1 and -2 on the y-axis? And this one has a y-intercept, oh, it's positive, like, looks like 1.5 on the y-axis. So which one is it? Which one's the correct y-intercept? How do we find a y-intercept? Do you remember that? So if you have a graph, let me just scribble a graph over here. You know, graph blah, 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 goes through a y-intercept. There's a y-intercept point. A y-intercept point has what kind of coordinates? Over 0, up some number. The x has to be 0, doesn't it? At a y-intercept point, at a place that hits the y-axis, the x value is 0. And vice versa. Right here, this is over some number up 0. His y-coordinate is 0. And this one is an x-intercept. So notice x-intercepts have a y value of 0. And y-intercepts have an x value of 0. The opposite letter is 0 for intercepts. That's for any graph. That's just the basic meaning of a y-intercept. X has got to be 0 because it's on the y-axis. Its x value is 0. And for an x-intercept, it's on the y-axis. I'm sorry, the x-axis, so its y value is 0. So the opposite letter is 0. So for a y, so it's good to know that and just commit that to your deep long-term memory. Intercepts have the opposite letter 0. So a y-intercept has x equal to 0. That's what it means, right? Look at this point right here. This is over 0 and then some y value, isn't it? And same thing here. This one. This point is over 0 and then some y value. The x value is 0. All right, so let's take this equation. Let me bring this formula on down here. X plus 2, x minus 3, so f of x plus 2, x minus 3 over x plus 1, x minus 4. So there's the original function, and this is y, right? The function value is y. So, in fact, it'd probably be better if I just wrote it right here. This is just y equals. Okay, and then what am I going to do? I'm going to take x equals 0, plug it in, plug it in, plug it in, plug it in. So y will equal 0 plus 2, 0 minus 3, 0 plus 1, 0 minus 4. So what's that? 2 times -3 over 1 times -4, which is what? -6 over -4, which is positive 1.5. You divide those in your calculator. 2 negatives make positive. So in other words, that's the point. Over 0 up positive, right? Because it came from an x value 0. We started with x 0, and that led to y 1.5. So that's the point. Over 0 up 1.5. Is it this one? No. This one is down 1.5 right here, isn't it? That's not the right graph. It must be this bottom one. There it is. That's over 0. Right there. That's over 0 up 1.5. That's the real answer. Select that one. That's the real graph because he has the right y-intercept over 0 up 1.5. He has the right vertical asymptotes and he has the right x-intercepts. That's the correct graph from the y-intercept. So there we go.